We're moving on to section 11.2, Gaussian Elimination. Now we're going to use the Gaussian elimination to solve systems of linear equations in 3 variables. And you could actually use it to solve systems with more than 3 variables, but we're going to just do 3 variables today. And we're also going to do some applied problems. So what is Gaussian elimination? Gaussian elimination is a way of approaching systems of equations with a specific goal in mind, that is, to get our systems of equations to look like ax plus by plus cz is equal to d, ey plus fz is equal to g, and hz is equal to k. In other words, there's 3 variables in our first equation, 2 variables in our second, 1 variable in our third. And if we can get our system of equations to look like this, then it's very easy to solve. We also have special rules about how to do this. The rules we follow are here. Rule 1. We can interchange or swap any 2 rows or equations. Rule 2. We can multiply both sides of any equation by a non-zero constant. And Rule 3. We can add elements of any equation to the corresponding elements of another equation. And these Rule 2 and 3 really are similar to the elimination method that we talked about in previous examples. It's sort of vague to talk about this in rules, so let's go ahead and apply these rules to our first example. We have our first system of equations written down, and I've labeled them. I've labeled the equations A, B, and C so that we can follow along with our work. And if you recall our goal, it's to have a system of equations with 3 variables in our first equation, 2 variables in our second, and 1 variable in our third. So my first goal is going to eliminate my x's twice. That is, I'm going to write my equation A first. I'm going to come up with a plan to get rid of my x's in my second and my third equation. And so that means for my second equation, I think I'm going to say b, which has a 3x, and I'm going to add to it 3 times c. And then my next one is going to be a, and I'm going to add to it 2 times c. Let's write that plan out a little bit more in depth. I'm going to say b here, I'm going to add to it 3c. And then again, I'm going to do a, I'm going to add to it 2c. Okay, so writing b, we get 3x minus 2y plus 4z is equal to 1. Writing 3c, I get negative 3x minus 9y plus 3z is equal to negative 30. My x's should be eliminated, and I end up with negative 11y plus 7z is equal to negative 29. I'll put that on this line. Negative 11y plus 7z is equal to negative 29. Let's do the next one. Let's eliminate our x's. We're going to write a as 2x plus y minus z is equal to 9. And then 2 times c gives me negative 2x minus 6y plus 2z is equal to negative 20. Our x's should get eliminated. I end up with negative 5y plus z is equal to negative 11. Let's write that here. Negative 5y plus z is equal to negative 11. Oh, and we haven't written our first equation, so let's write that in. We get 2x plus y minus z is equal to 9. We're halfway there. We've eliminated our x's, so now what we want to do is eliminate our y's. I'm just going to rename our second and our third equation so that they're easier to refer to. So let's just call them D and E. And to eliminate our y's, we're going to add a combination of D and E together. I want to make their coefficient 55, so we're going to multiply by 5 and by 11. But we do want them to have opposite signs, so we're going to multiply by 5 and then negative 11. Keep in mind, we already have equation A and D, because equation A has our 3 variables in it. Equation D has 2 variables in it. So it's only our third equation that we have to work on to get 1 variable in it. We've already decided we're going to do 5D minus 11E. So I get negative 55y plus 35z is equal to negative 145. And negative 11e gives me positive 55y minus 11z is equal to positive 121. Adding those together eliminates the y's, and I get 24z is equal to negative 24. So let me write that here. I get 24z is equal to negative 24. And let's just call that equation F. We now have our system of equations looking the way we want it. We have 3 variables in our first row, 2 variables in our second row, 1 variable in our third. And let's erase all of our work on the right hand side. That just frees up our screen so that we can use it to solve for x, y, and z now. And we're going to solve in reverse order because our last equation F only has 1 variable in it, so that's easy to solve. 24z is equal to negative 24, so we get z is equal to negative 1. Then we get negative 11y plus 7z is equal to negative 29. Plugging that value in, we put in negative 1. So now I get negative 11y minus 7 is equal to negative 29. In other words, negative 11y is equal to negative 22, or y is equal to positive 2. Taking all of that to plug into equation A, we get 2x plus y minus z is equal to 9. Our y is 2. Our z is negative 1. We get 2x plus 2 plus 1 is equal to 9. 2x plus 3 is equal to 9. 2x is equal to 6, or x is equal to 3. We're now ready to write our order triple. It is 3, 2, negative 1. You always want to write it in order of x, y, and z. So we sort of go in reverse order of how we solved it. And there you go. It's a lot of steps, but let's go over it methodically. We eliminate our x's twice. We rename our equations. We eliminate our y once. We rename that equation. That's then going to be in the Gaussian form, where we're able to solve for z first, then y next, and then x. Let's try this again. We're going to do the same steps, and we're going to eliminate our x's twice, but I'm also going to reorder it because I think I just like equation B. So I'm going to put that as our first equation. I like it because it has coefficients of 1. Then I want combinations to make my next 2 rows eliminate my x's. So I'm going to say A minus 2b and also C minus 3b. Equation B is x plus y plus 2z is equal to 3. Showing our work on the right, we'll write down A and negative 2b. I'll cancel out our x's, and I'll get 3y minus 5z is equal to negative 5. Let's write that down as our second equation. 3y minus 5z is equal to negative 5. So C is 3x plus 6y plus z is equal to negative 2, and negative 3b would give me negative 3x minus 3y minus 6z is equal to negative 9. Adding those together will eliminate the x's, and I'll be left with 3y minus 5z is equal to negative 11. So let's write that as our third line. 3y minus 5z is equal to negative 11. Let's go ahead and rename our second and our third equations as D and E. And our first equation is going to be B. X plus y plus 2z is equal to 3. Our next equation has two variables. It's equation D. 3y minus 5z is equal to negative 5. And then we want our third equation to eliminate our y's. So I'm going to say equation D minus E. So we'll say 3y minus 5z is equal to negative 5, and negative 3y plus 5z is equal to positive 11. And when I add those together, my y should cancel out, but also my z's end up canceling out. And I get 0 is equal to 6, which I'm going to write over here, but we should know that 0 does not equal 6. So there's no way that can be true. So this ends up being an inconsistent system. In other words, there's nothing we can do to make 0 equal to 6. So there's no solution. And remember that the way we write no solution is a 0 with a line through it. If instead we got something that was true, such as 0 is equal to 0, then that would be a consistent dependent system of equations, and that would have an infinite number of solutions. But when we get something that's not true, like 0 is equal to 6, then it's inconsistent system, and there is no solution. For question number 4, we have to set up our own system of equations. So we have to first understand what it is that we want to solve for. And it says, find the ways that Susan can invest her money. And so we want to find where we're going to put the $25,000 that she has inherited. And so we have 3 different savings funds, and we want to figure out how to put money into those savings funds. So the first thing we have to do is label our variables, x, y, and z. And each of those variables will stand for how much is invested in each of the savings funds, so at different percentages. Let's go ahead and set up some sentences as equations. Because we know she receives $25,000 from the inheritance and she's investing all of it, we know that the total amount invested is $25,000. So we can say x plus y plus z is $25,000. We also know how much percentage she gets on each of them. So she gets 3% on the amount invested in x. She gets 4% on the amount invested in y, and 6% on the z amount, for a total of $1,250. And that's all we know. Let's go ahead and label this as our A and B equations. Now, typically with a system of equations in 3 variables, you want to have at least 3 equations to solve it, but we only have 2. So we're going to solve it to the best of our abilities. And I just like to clear my decimals, so I multiplied my second equation by 100 to get rid of all my decimals. Now if I want to eliminate my x's, I want to have negative 3 times my first equation and add it to my second one. And I think that should have been negative 75,000. So adding that together, my x's will cancel out. I get y plus 3z is equal to 50,000. Let's call this equation We want to eliminate y's by adding and subtracting a and c. And we'll get x minus 2z is equal to negative 25,000. You might be wondering, what are we going to do with all of this information? What I'm going to do is take these two equations that I solved for, equation C and equation D, and each of these are only in 2 variables, no longer in 3 variables. And we're going to solve for y and solve for z, or we're going to solve for y and solve for x. The nice thing about this is that we've now isolated both our x and our y, and we put them in terms of z. In other words, we've come up with a system of equations where our x depends on our value of z, our y depends on our value of z, and our z is our z. And so if we pick a z, then we can figure out what numbers we have invested in every single account. What we've done is solved for a system where if I figure out a value for z, then I can figure out all the other values. What happens if I invest $0 into the z? Well, then that makes the amount I invested into x a negative value. So the second part of this question says, find the bounds on z such that all interest earned from the 3 savings bonds is non-negative. I'm going to do this by graphing each of these equations, and if I graph it, then I can find out what values z can be so that x and y and z will all be non-negative. I just want to point out that when you graph in Desmos, x and y mean something specific. So if I want to have these, I label them as the x function. I wrote it as a capital X, because capital X is not the same thing as lowercase x. And so my function is capital X with the z being my variable, and my other one is capital Y with my z being the variable. And so I was able to graph it, and notice that my x values are positive only when my z values are greater than 12,500. And my y values are positive only when my z value is less than 16,666. So my z values can be literally just between these two values, and if my z is between 12,500 or less than 16,666 and 67 cents, then all my values will be positive. So as long as she invests $12,500 up to $16,666.67 into the Z account, then the other two numbers will also be positive value that she invests. Thank you. That's the entire section. Go practice and have a good day.